In this video, I'm going to talk about absolute value equations and inequalities. So, as a reminder, you've learned about absolute value before, or you should have. Absolute value just means the distance a number is from zero. So, absolute value is the distance a number is from zero. So, and the way that I represent absolute value is two bars like that. So if I asked you what's the absolute value of 6, you would tell me that how many units is 6 from 0? Well, we know it's 6 units from 0. So the answer is 6. If I had the absolute value of -6, if I counted how many units -6 was from 0, it would also be 6. So because absolute value represents the distance, and distance can never be negative, the answer to an absolute value problem always has to be a positive number. So if I had, for example, the absolute value of x is equal to 2, I would know that there's two things that I could plug in here for x, where that statement would be true. One thing that I could plug in for x is I could say x is equal to 2, because I know that if I plug in 2 in for x, this statement is true. The absolute value of 2 is equal to 2. I could also say, or I could say x is equal to, something else I could plug in is -2, because I know that the absolute value of -2 is equal to +2 as well, and that statement will be true. So when I have an absolute value equation like this, I know most of the time I'm going to have two answers. So I'm going to be able to write two equations from that absolute value equation. That brings us to our next point, which is solving absolute value equations. So the first step to solving absolute value equations is always to isolate the absolute value. So you want to get that absolute value by itself. You want to isolate the absolute value. What you never ever want to do is you never want to distribute. So never distribute. And we're going to talk about what that means. If I have an equation that looks like this, 3 times the absolute value of x plus 1 is equal to 2. I am never, ever, ever going to distribute that 3 into the absolute value bars. So I never want to write 3x plus 1, the absolute value of that is equal to 2. I don't want to do that. What I want to do instead is I want to isolate that absolute value, and the way I'm going to do that is, well, right here I'm multiplying that absolute value by 3, so I want to get rid of that multiplying by 3, and to undo that I divide by 3. If I do that on the left, I have to do that on the right, so I'm going to end up with the absolute value of x plus 1 is equal to 2/3, and I have now my absolute value isolated. We're going to talk more about that later, but never ever distribute a number into the absolute value bars. All right, the second step, like we did up here, is to write two equations. Sometimes you're not going to be able to write two equations, but most of the time you're going to write two equations, and we'll talk about the exceptions that there are. But the second step is usually to write two equations. One positive and one negative. One with whatever is inside of the absolute value being positive, the other whatever's inside the absolute value being equal to the negative version. The third step is to solve and graph. So third step is to solve and graph. Those are our 3 steps. We're going to talk about the number of solutions that you could possibly have. So like I had just said, most of the time you're going to write two equations because there's going to be two answers. So there are usually two solutions. Two solutions to an absolute value equation. That is the case when you have the absolute value of something is equal to a positive number. So if I have the absolute value of x is equal to a positive number, so something like the absolute value of x is equal to 3. If I see something like that, where there's a positive number on the right-hand side, that's going, or the opposite side of the absolute value, it's going to tell me that I have 2 solutions. So this means 2 solutions. If I see that the absolute value of x, I've isolated the absolute value and I see it's equal to a negative number, so I see something like, and it might not just be x by itself and the absolute value, I might see something like the absolute value of x plus 3 is equal to negative 3. If I see something like that where I have an absolute value is equal to a negative number, that doesn't make sense because we said that absolute value represents distance and that can never be negative. So for these examples, I'm going to put no solution. I don't have to write, I don't even have to do step 2 because I know it's no solution. The third scenario that you'll see is when you get the absolute value by itself, it's equal to 0. That means there's just one solution because 0 is not positive or negative, so you can't write 2 different equations. You can only write one equation from this point. Okay. So you either have one solution, 2 solutions, or no solution. All right, let's do an example. So if I have 3 times the absolute value of x minus 4 is equal to 5. The first thing that I want to do is I want to isolate. I want to get this absolute value by itself. So the first thing that I'm going to do is undo what's being done to it. In case you don't remember, the order of operations is PEMDAS. That's the order in which I do operations. So the order in which I undo operations would be the opposite. It would be SADMEP. And you probably have never heard that before, but that's how you can always remember the order in which you undo operations. So the first one that we undo is subtraction. I see subtraction here. I'm subtracting by 4. So the first thing that I want to do is undo that. And to undo minusing 4, I add 4. If I do that on the left, I got to do that on the right. Got to keep my equation balanced. So I have now 3 times the absolute value of x is equal to 9. Next thing I want to do, well, right now I'm multiplying by 3, that absolute value by 3. I want to get it by itself, so I want to undo that by dividing by 3. I'm going to do that if I do that on the left, I have to do that on the right, and I'll end up with the absolute value of x is equal to 3. I never want to leave something like this. I always want to break it down so I don't have absolute value bars. So this was step 1. Step 1 was to isolate the absolute value. I isolated. I got that absolute value by itself on the left-hand side. Second thing I want to do is write the 2 equations. So one equation I can write from this is x is equal to 3. Whatever's inside the absolute value is equal to the positive version. Or I could write x is equal to negative 3. Those are my 2 options for what could be inside. Oops. So x could be 3 or x could be negative 3. Normally I would have to, that takes care of step 2. And then normally I would have to solve these 2 equations, but they're already solved for me. I don't have to do anything else. X is already by itself. So I'm just going to graph. I'm going to put negative 3 and 3 on a number line. Those are the important points. For important numbers, and I'm going to plot the answers by just putting a solid dot on those 2 numbers. And that takes care of step 3. Okay, and I'm done. All right, let's look at this problem. So if I have 2 times the absolute value of x plus 1 minus 3 is equal to 3, first thing I want to do is isolate this absolute value and I get it by itself. So I'm going to first undo the subtraction by adding 3 on both sides. I'll get 2 times the absolute value of x plus 1 is equal to 6. The next thing I want to do is divide by 2 on both sides, undo the multiplying by 2, I'll get the absolute value of x plus 1 is equal to 3. Now I have an absolute value by itself. Step 1 is done. I isolated. This absolute value is by itself on the left-hand side. Next thing I'm going to do, I want to say, well, x plus 1 could be equal to, what could I put in instead of x plus 1? What could I substitute it with? I could say, for the absolute value of it to be 3, I could say, well, one option is for that blob, that thing inside the absolute value of x plus 1 to be equal to positive 3. The other thing I could say, other thing I could do is say that that blob, x plus 1, could also be, it could be equal to negative 3. If I made x plus 1 equal to negative 3, I would have negative 3, the absolute value of that is equal to 3, which is true. So those are the two things that I can set x plus 1 equal to that would make the absolute value equation true. So these are the two equations. That takes care of step 2. I wrote the two equations. And now I'm going to solve. So I'm going to subtract 1 on both sides. I'm going to get x is equal to 2. Or I'm going to subtract 1 on both sides here. And I get x is equal to negative 4. So x is equal to positive 2 or x is equal to negative 4. Those are my two solutions. And I'm just going to graph them by putting them on a number line and plotting them. All right. Next example, I have negative 4 times x plus 5. The absolute value of that is equal to 20. First thing I want to do, isolate the absolute value, get it by itself. So I'm going to divide both sides by 4, negative 4. I'm going to get the absolute value of x plus 5 is equal to negative 5. From there, I can see I have the absolute value of something is equal to a negative number. Well, I can't have a negative number. I can't have absolute value is equal to a negative number. I know if I see something like this, that means that there is no solution. I don't even have to do anything else. I can just say there's no solution because that's not possible. Distance can't be negative. All right, let's next talk about solving absolute value inequalities. The steps are basically the same for solving the absolute value equations. The first thing that you're going to do is you're going to isolate the absolute value. Isolate the absolute value. That's step 1. The second thing you're going to do, same thing, except just a little bit different. You're going to write two inequalities. Instead of two equations, you're going to write two inequalities. So write two inequalities. The third thing that you're going to do is your same thing as before. You're going to solve and graph. These graphs are going to look a little bit different. You're not just going to have two answers. You're going to have an infinite amount of answers. So you'll need to shade on the number line. I'm just going to talk in a little bit more detail about the second step. So writing those two inequalities. There are two cases that we'll see with absolute value inequalities. We might see that the absolute value of something is greater than a number. The other case that we'll see is the absolute value is less than some number. If I isolate my absolute value and I get the absolute value of something is greater than a number, so greater, I know that the word in between the two inequalities that I write is going to be or, and I'm going to remember that by thinking great or. If I see, if I've isolated the absolute value and I see I have greater than, that means I'm going to have or as the word in between my two inequalities. So to clarify what this means, what it means if I see this after I isolate, it means I'm going to drop the absolute value bars. That's what I want to do. I want to get rid of them. The first inequality I'm going to write is x is greater than a. The second inequality that I'm going to write, but the word that's going to separate them is or. Second inequality is x is, I'm going to change this. I'm going to change this sign to be the opposite, so it's going to be less than instead of greater than. And I'm going to change this number to be the opposite, so it's going to be negative a instead of positive a. So if I see that the absolute value of x is greater than a, the two inequalities I'm going to write is x is greater than a, or x is less than negative a. And it's really important that I have this or in between. So if you have greater, remember great or. All right, the other scenario is if I have, let me just separate this. If I have the absolute value of x is less than a, if I have that, the way I'm going to remember the word that goes in between the two inequalities I write is less than. I'm going to say less than, and that's going to make it easy for me to remember that and is the word that goes in between the two inequalities that I write when I have this scenario. So it means if the absolute value of x is less than a, it means x is less than a and x is greater than, so the opposite of negative a, the opposite of a. Okay, so this is what I'll write. There's another way that I can write that. If I have the absolute value of something is less than, I can also write these two inequalities as one inequality. I can write negative a is less than x, which is less than positive a. The reason I can do that is this is a compound inequality. It means that if you say this statement, it means that the solution is in between two numbers. In between negative a and positive a. All right, let's try an example. So if I have 3 minus x, the absolute value of that, minus 2 is greater than 7, the first thing I'm going to do is I'm going to isolate this absolute value. So I'm going to add 2 on both sides to get that absolute value by itself. That's going to give me the absolute value of 3 minus x is greater than 9. Now I have an isolated absolute value by itself is greater than a number. So I have great or. That means that the word that goes in between the two inequalities that I write is or. So the first inequality, all I'm doing is dropping the absolute value bars. I'm going to have 3 minus x is greater than 9. Or, because I have greater than, I'm going to write 3 minus x is the opposite of greater than, so less than, and the opposite of 9, so negative 9. These are my two inequalities. These are the two inequalities that I'm going to solve. So the first thing I'm going to do is I'm going to subtract 3 on both sides to get that, to eventually get the x by itself. If I can do that in this inequality, I can do that in this inequality as well. So the steps are going to be the same. You can do them all at the same time for the two inequalities that you write. So I'm going to subtract 3 on both sides. I'm going to get negative x is greater than 6, or negative x is less than negative 12. The next thing I'm going to do, I don't want a negative in front of my x. I want x by itself. I want to know what the solutions are for the variable, not for the negative version of the variable. So I'm going to get rid of that negative sign. I know that it actually means when I have a negative sign in front of a variable that there's a negative 1 in front. So I'm going to divide both sides. I'm going to get rid of that multiplying by the negative 1 by dividing both sides by negative 1. If I do that in the left-hand side, I could do that on the right-hand side as well, in the right inequality as well. All right, so when I do that, I'm going to get x is, when I divide or multiply an inequality by a negative number, I know that that changes the sign. So if the sign is greater than, it's going to become less than. So x is less than negative 6. 6 divided by negative 1 is negative 6. Or x is, it's going to change from less than to greater than positive 12. So I have x is less than negative 6 or x is greater than positive 12. I'm going to draw a number line. I'm going to put those two important numbers, and I'm going to start shading. So I know x is less than negative 6. What that looks like on the graph is negative 6 is not included. It's not included, so I'm going to put an open circle on it, not a shaded dot. And then I'm going to shade everything, since it's less than, I'm going to shade everything to the left of negative 6 on the number line. So I took care of x is less than negative 6. That's done. Now I'm looking at x is greater than 12. So I know, again, that 12 is not included because I don't see x is greater than or equal to 12. I just see x is greater than 12. So I'm going to put an open circle on 12 and shade everything to the right. And this is my number line solution, the graph. Okay, for example 2, first thing I'm going to do, isolate the absolute value by subtracting 3 on both sides. I get 3x minus 6. The absolute value of that is less than 12. I've got the absolute value isolated by itself. Now I can move on to step 2. That step 1 is done. Because I see less than, I know that I have less. I can remember what word goes in between my two inequalities by saying less than in my head. And I know and goes in between. So I have 3x minus 6 is less than 12 is the first inequality that I write. I just drop these absolute value bars. I just rewrite whatever I have if I drop those bars. And, because I know and goes in between, my second inequality is 3x minus 6. I'm changing this less than sign to a greater than sign. I'm changing this 12 to negative 12. Those are my two inequalities. Step 2 is done. Third step is to solve and graph. So the first thing I want to do is I want to undo whatever is happening to that x. So first thing I undo is subtraction. I'm adding 6 on both sides. Like I said, if you could do that in the left inequality, you can do it in the right inequality. So I'm going to add 6 on both sides to the right inequality as well. I'm going to get 3x is less than 18, and 3x is greater than negative 6. From there, I'm going to divide both sides by 3 in both inequalities, and I'm going to get x is less than 6, and x is greater than negative 2. I'm going to graph this, put those important points, negative 2, positive 6. To graph x is less than 6, I'm not going to graph it yet, but I'm going to put an open circle on 6, and I know I'm going to shade everything to the left. To graph x is greater than negative 2, I'm going to put an open circle on negative 2 and shade everything to the right. This means that I can't shade, it has to be greater than negative 2 and less than negative 6. So I can't shade this part here, and I can't shade this part here. I can only shade in between those two numbers. The solutions are all the numbers in between negative 2 and 6. I can plug in any number from negative 2 to 6 into this, and this statement is true. So if we want to try, if we do that, let's pick a number, let's put in 0. I can actually use this inequality because it's easier. If I plug in 0, I have 3 times 0 minus 6. The absolute value of that is less than 12. Is that true? Well, 0 minus 6. I have negative 6. The absolute value of that, is that less than 12? Yes, it is, because the absolute value of negative 6 is 6, and 6 is less than 12. So that works. It would work for any number in between. That's what your graph tells you.